This is AP Calculus AB. We are on the pretest for applications of derivatives. If you are merely here to check your work, go ahead and check it using this page. Again, make sure that you are checking your work in the video with any question that you got wrong or any question that you guessed on. Let's dive in. In number one, we're trying to find the equation of a tangent line. Anytime that we have an equation of a tangent line, we will always do y minus box is equal to box times x minus box using that point slope form. It gives us the x coordinate of 1, therefore we plug in a 1. It gives us a y coordinate of 5, therefore we plug in a 5. The only thing that it does not give us is what the slope is. So we need to find the slope, therefore we need to take the derivative. Unfortunately, the derivative of a fraction means we are invoking quotient rule. As a reminder, quotient rule is low times d high minus high times d low all over low or low squared. All right, our low is 3x minus 2. The derivative of high, the derivative of the numerator, is 2 minus high. High is the numerator, 2x plus 3. And that is multiplied by the derivative of the denominator, d low, which is just 3. This is all going to be divided by the derivative of just low, which is 3x minus 2 quantity squared. And I'm realizing for the sake of consistency, I should be writing parentheses around everything. All right, immediately I'm going to plug in x is equal to 1. And this will make this, here, let me just plug in a 1 by saying that's a 1, that's a 1, and that is a 1. Simplifying this, I can say that 3 times 1 is 1, and 3 minus 2 is also 1. Times 2, I'll say times 2, minus, and then I'm going to say 2 times 1 is 2, 2 plus 3 is 5, so I can say that's all 5, and then I'll say times 3. The denominator is going to be 3 times 1, which is 3, 3 minus 2 is 1, and 1 to the power of 2 is 1. Simplifying yet again, 1 times 2 is 2, 5 times 3 is 15, and 2 minus 15 is negative 13. And that means I can plug in my slope over here of negative 13. I have my equation. I'm just trying to find the right option now. I'm noticing that they try to put both their x's and the y's on the left-hand side for all of these, and they're constant on the right-hand side. Let's go ahead and distribute and see what happens. When I distribute, I have a negative 13x on the right-hand side and a positive 13 also on the right-hand side. And I have y minus 5 on the left-hand side. Let's move the x to the left, so I have a positive 13. I'm going to put the x out front, 13x plus y on the right, or on the left-hand side. This 5 is going to move to the right-hand side by adding 5, and this will be equal to 18. 13x plus y is equal to 18 is option B. Moving on to number 2. In number 2, we are trying to find, again, an equation of a line tangent. That means we're using point slope form yet again. Y minus box is equal to box times x minus box. Fill in the boxes. The x coordinate is negative 1, therefore I fill in the x coordinate is negative 1. It unfortunately does not give me the y coordinate, so I need to find it on my own. Let's do some scratch work on the side. To find f of negative 1, we need to plug in negative 1, and we have 4 times the quantity of negative 1. I'll write that in at the very end. Cubed minus 5. Ooh, that's supposed to be a 5. 5 times my x plus 3. And I'm plugging in a negative 1 for each of these. When I do this, I'm left with a negative 4 plus 5 plus 3. Again, my shortcut is whenever I see an odd power, I keep it negative. All right, adding these together, negative 4 plus 5 is 1, 1 plus 3 is 4. This will be equal to a 4 for my y-coordinate, plugging in a 4 for my y-coordinate. And then from there, I'm going to take the derivative in order to find my slope. I'm going to find f prime. Let's go ahead and do that now. F prime of x means that this 3 is going to be multiplied down. 3 times 4 is 12, so I'll have a 12x to the power of 2 minus 5. And then from there, we need to simply plug in our negative 1. So this is going to be f prime of my negative 1. This means I have 12 times my negative 1 squared minus 5. Let's write in the negative 1 with a different color. And again, now that I have an even power, I'm going to have a positive base. So I'll say 12 times 1 minus 5 is 7. Therefore, I can say my slope over here is 7. Now that I have my answer. I just need to get it in the correct form. I'm noticing that I write it in slope-intercept form, so I'll need to distribute the 7, and I'll need to bring that 4 to the other side. I'm going to do those in 2 separate steps. I'll still have y minus 4 on the left-hand side. Distributing the positive 7 gives us a 7x. This is really a negative times a negative is a positive, so a 7 times a positive 1 is a positive 7. From there, add 4 to both sides, leaving y is equal to 7x plus 11. Our final answer is option C. Moving on to number 3. In number 3, we're trying to find an approximation using the, here, let's zoom out a little bit, line tangent to the graph, which means, again, we are using that point slope form. Y minus box is equal to box times x minus box. What x coordinate are we using? We're using 0. Plug in our 0 to our x coordinate. What y coordinate are we using? Well, it tells us when the x coordinate is 0, the y coordinate is 1. So I can say that the y coordinate is 1 over here. And it even took the derivative for us and said the derivative is 3x minus 2. We need to plug in our x coordinate 0 into our x. Let's go ahead and do that for our scratch work over here. Scratch work f prime of 0, and I should maybe make that 0 pop a little bit. F prime of 0 is equal to 3 times that x minus 2. That x is now a 0. So I can say this is going to be 3 times 0 is 0. 0 minus 2 is a negative 2. Therefore, our slope is a negative 2. Now that we have our tangent line to the graph, we will plug in what we want to approximate. We want to approximate 0.1. That gets plugged in for x. So if I come back over here, I can now say that y minus 1 is equal to negative 2 times the quantity of 0.1, and then minus 0. 0.1 minus 0 is 0.1, and 0.1 times a negative 2 is a negative 0.2. Negative 0.2. And I will have to add 1 to both sides. When I add 1 to both sides, I get 0.8. Our final answer is option C. Moving on to number 4. Again, we're looking for a line tangent to the graph, which means yet again, we're doing point slope form. Y minus box is equal to box times x minus box. What is our x coordinate? Our x coordinate is pi over 4. Plug in your pi divided by 4. Does it give us our y coordinate? No, we've got to find it on our own. Plug in x into our equation, and we will find the y coordinate. Let's do that just below, because I think once we have our point slope form, we'll be done. I'm noticing that all of our answers are also in point slope form. So when I do that, I have y is equal to cosine of 2 times my pi over 4. This is going to be the same thing as cosine of pi over 2. Cosine of pi over 2, if you forgot your trig values of special angles, pi over 2 is straight up. Cosine is how much right or left you're moving from the x-axis. We are not moving off the x-axis, therefore pi over 2 evaluates to 0. This evaluates to 0, and therefore our answer is just 0. All right, our y coordinate is 0. That's nice and easy. Ooh, I'm plugging it in. I want to change my color to blue. And then finally, we need to find the slope. To find the slope, we need to take the derivative of y. We need to find y prime. I'm running out of room. I think I can do it. Oh, wow, there's tons of room over here. Y prime is going to be equal to, okay, the derivative of cosine. It starts with the C. C stands for change. Therefore, it changes to a negative. And again, cosine and sine just flip-flop. So it changes into a negative sine of 2x. Don't forget your dinner. The derivative of the inner is not 1 this time. The derivative of the inner is 2. I will multiply by 2. Now that I have my derivative, I will again plug in pi over 4 into my x. Therefore, I have y prime is equal to negative sine of 2 times my pi over 4. Those are being multiplied together. And then after I get that, I will multiply the answer by 2. So what do we have here? It's going to be a negative sine of, this is going to be pi over 2 yet again. Now it's switched to sine, which is asking how far up or down are you going? Yes, we will still be multiplying by 2. I don't want to forget you. Pi over 2 lives right here. Sine is asking how much up or down did we go? Well, we went up all the way on a unit circle, meaning we went up 1. Sine of pi over 2 evaluates to just 1. So this is saying negative, I meant to do that with a laser pointer, negative 1 times 2. I can even write that again to make sure that my work is super clear. This is a negative 1 times 2, which is negative 2. Therefore, my slope is a negative 2. I have my equation. I'm looking for just a y by itself on the left-hand side, y by itself on the left-hand side, and I should be searching for a negative 2, and there's my rest of my equation. The correct answer here is option E for number 4. Moving on to number 5. In number 5, we are asked to find a related rate problem. Every single related rate problem can be summarized by taking the derivative and plugging and chugging. So let's first analyze what information is given to us. I see that the volume is increasing, therefore I know it's talking about a V prime. I'm going to put that V prime over here. V prime is equal to, is it positive or negative? Increasing is a positive word, meaning I have a positive 12. What other information is given to me? Maybe we can do this in a different color. It says that the volume is 36 pi, therefore volume without a prime is just 36 pi. And from there, I need to ask the question, how fast is the surface area increasing? Therefore, it's talking about surface area prime is equal to box. That's what I'm trying to solve for. Because I see that I'm given f or v prime and s prime, I know that I'm going to be taking the derivative of v and the derivative of s, since those both show up in my problem. Let's go ahead and get that out of the way right now. Taking the derivative of v means this 3 is going to come down in front, and that 3 and 3 will cross cancel, leaving behind just a 4 pi r squared. Don't forget your dinner. So v prime is going to be equal to 4 pi r squared, and the derivative of r is r prime, so let's put that now. Taking the derivative of surface area gives you surface area prime, which is equal to, 2 comes down in front, 2 times 4 is an 8. So we have 8 pi r, don't forget your r prime. We have both of our formulas. Let's plug in what we know. I also know that I have a v is equal to 36 pi. Oh boy, I have to use that too later. First, let's slow down. V prime is equal to 12. This v prime is equal to a 12. So I can come down here and say 12, I'm doing a substitution, I'll plug in with blue, is equal to 4 pi. All right, well, I don't have any of this, so I'm just going to leave it blank. There's my r squared, and there's my r prime. No idea what's going on there. Let's just move on to the next equation. I'm literally just plugging and seeing what happens. Plugging and chugging, right? S prime. Well, obviously, I don't know what that is, because if I did, I would be done with the problem. So let's leave that S prime. Whoa, don't know why that happened. And therefore S prime is going to be equal to 8 times pi times radius, which I don't know, times radius prime, which again I don't know. Seems like I'm just spinning my wheels here. Okay, well, what is a piece of information we haven't used yet? The fact that v is equal to 36 pi. So let's go ahead and just rewrite my equation for v down and see what happens. So let's zoom in out just enough where we can write and see the formula. Volume is equal to 4 pi, there's my r. I'm just going to write r. R to the power of 3 all over 3. And I happen to know, hey, look, volume is equal to 36 pi, which means this volume is 36 pi. So I can come over here and say 36 pi is equal to 4 pi r cubed all divided by 3. And I'm noticing there's one variable, and I can solve for that one variable, which will be really nice. All right, so what do we have going on over here? I'm going to multiply both sides by 3 first. No, that's too big. Let's divide both sides by 4 first. 36 divided by 4 is 9. So I will say, how slowly should I go? Yeah, I think I'll go nice and slow for the video. I'll say, now I have 9 pi is equal to pi r to the power 3 divided by 3, and then I'm going to multiply by 3. If I multiply by 3, now I get 27, and I can divide both sides by pi. If I divide by pi, those are both gone. So multiplying by 3 gives us 27 on the left-hand side, and r to the power 3 on the right-hand side, and I realize I just need room for one more line, so you are going to move up just a wee bit, and if I take the cube root of 27, you should know that's 3. 3 is equal to r. All right, so now that I know a value of r, I can plug in 3 everywhere. I can say, hey, this r is 3. This r over here is also 3. And, oh, that means I have one variable unknown. I'm going to get rid of the empty spot and change that into an r prime. R prime, because now in this equation, I have one unknown variable that I can now solve for, right? I can say over here, let's go ahead and say that the 3 squared is really just a 9. So let's simplify. I have 9 times 4, which is 36. I really have a 36 pi r prime on the right and a 12 on the left. If I divide both sides by 36 pi, I get r prime on the right, and I have a 12 divided by this 36 pi on the left. And that can be reduced, right? So I can come over here and say this will be, I'm moving to the left, which is a little bit abnormal, but I can divide both the numerator and denominator by 12, and I get 1 over 3 pi. So I know what r prime is, and hey, look over here, I have an r prime that I now know. r prime is this 1 over 3 pi, so I'm going to write 1 over 3 pi in here, and oh, that worked out really nice. Watch all this stuff cancel out. 3, 3, gone and gone. Pi, pi, gone and gone. The only thing that's left there is 8. Therefore, s prime is equal to 8. Kind of nice. Is 8 an answer? A is an answer. Number 5, the answer is A. All right. Number 6, another related rate problem. So it says that the radius is increasing. Okay, it's positive. The rate of the increase of the area. Okay, so this has a meaning, and I'm going to write it up above it. Let me highlight you. Maybe I'll just underline you. The rate of increase of the area means area prime. Is numerically equal to means write the equal to sign. This word twice here means multiply by 2, and the rate of increase of its circumference means circumference prime. That's it. That's everything. I need to turn that into an equation, I suppose. What is the radius of the circle at that instant? That means I'm looking for what is r prime. That's the question. So I'm going to set up the formula by writing area prime is equal to 2 times something, 2 times something, times c prime, times c prime. Okay, so there's the equation. It really hidden, like it gave it to us in words, which is weird, but whatever. Okay, we know how to do that. And we somehow need to get an r prime. Well, this problem is hard unless you remember one of those key facts that I told you at the beginning of the year, which is area prime and circumference prime are basically the same if you multiply circumference prime by r. Now they're exactly the same. And hey, if area prime is c prime times r, this area prime is also c prime times r. So let me go ahead and swap that out. I can say this c prime times r is going to be plugged in to this a prime, meaning I have c prime r, which is equal to 2c prime. And now I can divide both sides by c prime. When I do that, the c primes are gone, leaving behind r is equal to 2. All right, correct answer here is D. You probably saw that on the self-check, though. All right, number 7. We have a graph. We are asked about a limit question, which is like a unit 1 question. All right, so it's saying when I approach c from both sides, so when I approach, I don't know, maybe it's 2. When I approach that point from both sides, do I get a height of 1? Okay, well, a height of 1 is kind of a giveaway. If it's a height of 1, I can go ahead and just kind of make a line here at 1. Well, that was a terrible line. Okay, thank you, technology. This height of 1 is right there. Where do I have a height of 1? Well, I have a height of 1. I have a highlighter tool. Might as well use it, right? I have a height of 1 here, here, and here. All right, so when do I have a height of 1? When the double-sided limit, when I approach it from both sides. So as I approach from both sides, do I approach a height of 1? Yes, so let me go ahead and circle. -2 is an option. What about this one? When I approach from the left and when I approach the right, am I approaching the same height? Yes, also that one is there, which is 0. And when I approach from the left and I approach from the right, or am I approaching the same height? No, it's a sad face, right? Sad face. Nope, not that one. I don't want to annotate that that's a sad face, but I am bad at drawing. All right, so there's only 2 answers, and it's -2 and 0. -2 and 0 is option C. And it appears I have accidentally shown how to do that question, but I want to walk through it. So let's go ahead and do number 8 now. In number 8, we are asked to find y prime. This question is really hard. Let me show you why. First, we have to take the derivative of e house. E house is kind of nice because to take the derivative of e house, it's just e house. It's e to the power of x, y.
Oh my God.
But then the hard part about this is the derivative of the inner. I need to take the derivative of x, y, and yes, that does mean you're doing product rule, which is 1d2 plus 2d1. So this entire thing is going to be multiplied by 1d2, so that's 1d2 plus 2d1, and d1, the derivative of x is just 1. So there's the first derivative. Now I'm going to write down the minus sign, and the derivative of y squared is 2y, or again, this 2 goes down to a power of 1, so there's my power of 1, and then I take the derivative of y, which is y prime again. This is going to be equal to, okay, these seem like it's e house, like e to the power of x. You're going to write e to the power of x, right? But there's no x. This is just a number. E is about like 2.7-ish. So this is just a number minus another number. The derivative of a number is just 0. The derivative of a constant is always 0. And as soon as you can, you want to plug in both your x and your y value. My x value is 1/2. My y value is 2. Plug them in now. So when I do that, this is going to be e to the power of x is 1/2 times y, which is 2, all times x, which is 1/2 times y prime, plus y, which is 2, minus 2. What's my y? My y is 2. I realize I haven't been color coding these. Let me go back and color code these. Times y prime. And that's equal to 0. So all of these, I'm plugging in numbers. I do want to swap those out for the color of blue. So let's go ahead and erase those. Whoa, that eraser is way too big. That 2 is being plugged in. That 1/2 should be blue as well. I like making things look nice and organized. And the 1/2 times 2 should have been blue as well. 1/2 times 2. All right, that looks like it's much neater. Let's see if I have enough room to do one more step underneath here. Where do you got? Okay, so there's gonna be I'm gonna do a few things at the same time. Hopefully you can keep up with me. 1/2 times 2 is 1. So this is really e to the power of 1, which is just e. This whole thing is just e. And I'm going to distribute that e into these two terms to see what happens. And you'll see why we have to do that in a little bit. This is going to be e halves. I distributed e times 1/2 times my y prime plus, okay, I'm distributing the e into the 2, so I get a 2e minus 4y prime is equal to 0. The reason I wanted to distribute the e is because I don't want to have to worry about any sort of multiplication. I simply want a bunch of terms, and I want to distinguish between which ones have a y prime and which ones do not. You'll notice this 2e does not have a y prime, which means I'm going to move it to the other side. When I do that, I'm left with e over 2, y prime, where's my y prime? Y prime, there we go, minus 4y prime is equal to a negative 2e. Now all of my y prime terms are on the left-hand side, and my non-y prime terms are on the right-hand side. Now I'm going to factor out my y prime terms, meaning I'm dividing by y prime, dividing by y prime. That is a terrible y prime, meaning my y prime term is factored out, leaving behind, okay, y prime term is gone, e over 2, minus, okay, y prime terms are gone, leaving behind a minus 4, so here's my minus 4, and that's still equal to a negative 2e. You'll notice that if I'm trying to get y prime by itself, the opposite of multiply by stuff is to divide by stuff. When I divide by stuff, all of this is going to be our denominator over here, meaning we finally have our answer, which is y prime is equal to negative 2e in the numerator, all divided by e over 2 minus 4 in the denominator. And now we try to look for that. And I'm noticing in all of these multiple choice answers, all of our e's are just e's, not divide by 2. So I need to get rid of that divide by 2. So you're allowed to multiply the bottom and top by a number. So I can multiply the bottom by 2 and the top by 2. And when I distribute that 2 into both of these, this e divided by 2 will just be a normal e. So what does that look like? This is the same thing as a negative 4e in the numerator and just a normal e minus 8. Ooh, that was a terrible 8 in the denominator. Let's look for u. I am not seeing a negative out in front or in the top, which means we have to do yet another step. So if that doesn't work, you can always multiply the top and bottom by a negative 1. So times by a negative 1 times by a negative 1. And now I have a positive 4e in the numerator and a negative e plus 8 in the denominator. So let's see if I'm looking for that one. Do I see a 4e in the numerator? Okay, I see two 4e's. I see negative e plus 8. Okay, there's my negative e. Oh, there's my negative e plus 8. Whew. All right, we got it. Correct answer is C. Lots and lots of math in that one. Crazy. All right, moving on to number 9. In number 9, we have the Pythagorean theorem. I'm going to rewrite the input because this is difficult to determine what's going on. This is saying that z prime is equal to 1. This is saying x prime is equal to a 3y prime. And it's also telling us, okay, x is equals 4, don't need to rewrite u. Y is equal to 3, don't need to write u. And then this is asking for x prime. X prime is a question. All right, so let's go ahead and write out the derivative of the Pythagorean theorem, which you should have down. It's going to be x prime plus y prime, y prime is equal to z prime. Let's plug in everything that we know, which is a great place to start. So I happen to know that z prime is 1. So let's go ahead and say z prime right here is 1. What else do we know? We know that x prime is equal to 3y prime. We'll come back to that one. I'm not sure if we should just swap out the x prime for a 3y prime right off the bat, because if we do that, we'll have no x prime term, and we're trying to find an xy or x prime term, so I'm nervous to use that one. We'll come back. We see x is 4, so there we go. And I'm seeing that y is 3, so y is equal to 3. Okay, so I'm noticing that we have two static values that are not changing. This x, I'm just going to label that as well, is a 4. This y is a 3, and hopefully you have this one memorized. This is a 3, 4 what triangle? Yes, it's a 3, 4, 5 triangle. This is one of the Pythagorean triples that you should know, but if you don't know, you can always plug 3 and 4 into the Pythagorean theorem for the legs to find that 5 is indeed the hypotenuse. So I know that z is 5. I can come down here and say that this is 5. And basically I just need to choose y prime and x prime in such a way that I can solve for x prime. So if I'm trying to solve for x prime, this x prime should probably just stay as x prime. Let me rewrite my x prime. The next thing that I'm noticing is I need to somehow swap out my y prime. The only thing that I really have to play with is the fact that y prime is down here. So I can actually move this 3 to the other side, and then I'll get y prime by itself, and I'll know what this y prime is equal to. So I can come down here and divide both sides by 3. And when I divide both sides by 3, I get y prime is equal to x prime over 3. So I now know that if this y prime is x prime over 3, this y prime is also x prime over 3. I can say this is times x prime over 3, which is kind of fantastic because look, this 3 and this 3 are going to cross cancel, and we are going to be, let me write that down, we're going to be left with just an x prime here. So let's go ahead and simplify all of this. This is going to be 4x prime plus another x prime is equal to, here's my equal to, is equal to 5. And check this out, I have 5x prime is equal to 5. If we divide both sides by 5, we get x prime is equal to 1. So let me move all this so I can show that work. Move you up a little bit. Divide both sides by 5, and x prime is equal to 1. And we have solved the problem. Come down here. The correct answer here is B. It's 1. For number 10, we're asked to find the second derivative. This is the way that you say y double prime. So let me go ahead and say this is y double prime. So in order to find y double prime, we need to first find y prime. So let's do that now. Y prime. Okay, so taking the derivative, the c here stands for change, as in change the sign. It was positive and now it's negative. So negative 2, and then cosine and sine always flip-flop. So it's negative 2 sine of x over 2. That is the derivative of the outer. Don't forget your dinner. Don't forget the derivative of x over 2 is 1/2. So I'm going to be multiplying by 1/2. And you'll notice that the 1/2 and the 2 will cross cancel. Therefore, I'm left with just negative sine of x over 2. All right, that was y prime. I now need to take the derivative again. Take the derivative of the left, take the derivative of the right. So if I take the derivative of a negative sign, well, S stands for same sign, as in it is staying a negative. So it's negative, and sine and cosine always flip-flop. So this is now cosine of x over 2. And remember to multiply by the derivative of the inner, the dinner, which is now 1/2. So there's our derivative, and I'm just looking for that one. I should have like a negative 1/2 out in front, I'm expecting. There's the negative 1/2, and let's check the rest. Yep, cosine of x over 2. Looks like the correct answer here is E for number 10. Let's move on to number 11. Number 11 is a review question. Okay, cool. This is basically saying we are given a graph of y. All of these are graphs of y. It says y on each of these, which is kind of, well, I guess that doesn't explain this y, but these are all just a graph of y. So y prime on a graph of y is slope. What this is saying is that the slope is, I don't know how to spell slope apparently, slope is a positive number. And on a graph of y prime, y double prime is concavity. So this is concave up. Wait, no, down, because this is less than 0. If it's less than 0, it's concave down. So we are looking for a graph everywhere. Notice it says for all x, everywhere where we have a positive slope. So positive slope, good, negative slope, bad. D has both a mixture of positive and negative slope, so it has to be only positive slope, and E only has positive slopes. So now we're between A, B, and E. Now we're going to use the second condition, that we need to be concave down for all x, everywhere. So concave up is unfortunately not concave down, so it's not A. B is concave down everywhere, so that is the correct answer. But why is E incorrect? Because it is a mixture of concave down and concave up. Let me go ahead and draw an arrow here and here to remind you. It is both a mixture of concave up and down, but it needs to be concave down for all x. correct answer for number 11, our review question, is B. Number 12, we are looking for values of x where the function is decreasing. So you need to remember the definition of decreasing. Decreasing is when f prime is less than 0, or when f prime is negative. Notice, because we are invoking the definition of f prime, we need f prime. So let's do that, f prime of x. All right, the derivative of a constant is 0, so go away. The derivative of 15x is 15. That is a terrible 5. That is a much better 5. Plus, okay, now we're in powerhouse. 2 comes down in front. 2 times a 6 is a 12. This is going to be 12x. It goes down to power to just 1. Minus, okay, and then 3x squared. We have the derivative correct. And I remember this question from an old pretest. This is really hard to do because when you do your factorization, it doesn't really work when you have a negative leading coefficient, because this is the same thing as saying negative 3x squared plus 12x plus 15. You'll notice that my leading coefficient, this negative 3, is negative, and that makes it really, really hard to factor. So in order to make this actually factorable, I'm going to get rid of that negative. And by getting rid of, I'm just going to divide by a negative. And I'm going to divide all of these by that negative. I'm going to factor out a negative, and then we're going to figure out what we're left with. Not only am I going to factor out a negative, I'm also going to factor out the greatest common factor. In this case, that's 3. I can divide all of them by 3, so I'm going to divide all of them by negative 3. If I divide all of them by negative 3, the negative 3 is factored out, and what's left over is an x squared minus 4x minus 5. And now this problem is much easier. I can say I have a negative 3, and then I'm going to have 2 different values. This is going to be x plus or minus something, x plus or minus something else. Hopefully you know the shortcut to factoring these quadratics, which is they need to multiply to the last term. Did you know that 5 only has 2 different ways to multiply? It's 1 times 5 and 5 times 1. So 1 and 5 are definitely going to be the answers. So it's going to be a 1 and a 5. And the only thing left to do is to make sure that these 2 numbers also add up to the middle. It needs to add up to a negative 4, meaning we take the sign of the larger negative. 5 must be the negative, and 1 must be the positive. Just double checking, a positive times a negative is a negative. We seem to be in good luck, or we're doing good. So that is my f prime of x. When I have my f prime of x, if I set it equal to 0, I can find the critical values where I could potentially switch signs, and that'll tell me all my intervals when f prime is less than 0. All right, so setting this equal to 0, I can divide both sides by negative 3 and kind of ignore it. And then I can also have x is equal to negative 1 from this linear factor, and x is equal to positive 5 from this linear factor. Now I have my x-intercepts. And I realize that I'm going through that a little bit fast, but this is a review problem. These are the values that will make me 0, essentially setting this equal to 0, which doesn't work, setting this equal to 0, giving us a value of negative 1, and setting this x minus 5 equal to 0, giving us an x value of 5. So next we're going to look at our sign chart. Our sign chart have 2 possible values that we're going to be putting on here. We have a negative 1 and a positive 5. Those are our critical values. The next thing that you want to do is you want to find where your intervals are positive and negative. Luckily, there's a shortcut. The shortcut is look at the leading coefficient, which is a negative. If the leading coefficient is a negative, the right-hand behavior will match the same sign as your leading coefficient. In this case, that will also be a negative. And because both of these powers, when it's factored, are odd, I am going to leapfrog over this and change signs. Again, if this had been an even power and you leapfrog over this, it would not have changed signs, although it would have been that power which corresponds to that critical value. So it's going to be a positive interval here, a negative interval here. And we're looking for an interval that is less than 0, that is negative. Well, it is negative to the right of 5, and I can even highlight that range. Everything over here is negative, and everything over here is also negative. So how do we say that? We say everything less than negative 1, less than negative 1, and everything greater than 5. Therefore, the correct answer here is D for number 12. Now I'm moving on to number 13. We're trying to describe relative extrema. Relative extrema is a fancy way of saying minimums and maximums. On points of inflection for the graph. So on this graph, sorry about that. On this graph, we have f prime. So if this is a graph of f prime, I'm going to be asking for the definitions of minimums and maximums as well as inflection points. So for a minimum, that is where f prime changes from a negative into a positive. For a maximum, that is where f prime changes from a positive into a negative. And for an inflection point, that is where f double prime, I was about to write 2 f's, f double prime changes sign. So I'll just say changes sign. All right, so we have a graph of f prime. What is f prime on a graph of f prime? Well, that's height. So do we have any heights that go from a negative to a positive? That would mean I'm coming down here and I'm coming up through the x-axis. No. No, I don't. Do I have any maximums? Do I have any heights that are going from a positive to a negative? Why, yes, we do. We have this positive height, and it comes down through here, and it switches to a negative height. So we have one relative maximum, and that maximum happens right here. Let's go ahead and annotate that. Maximum. Next, I'm going to do the analysis of my inflection point. My inflection point is where f double prime changes sign. So what is f double prime on a graph of f prime? That is a slope. So where does the slope change sign? Well, the slope is negative, slope is negative, slope is negative, slope is 0. But slope is still negative. It didn't change signs yet. Slope is negative, slope is negative, slope is positive. We change the slope right here. At this one spot, we have an inflection point. So which of these options says one maximum, one inflection point, and one maximum, one inflection point? Correct answer here is C. Moving on to number 14. In number 14, we are trying to plug in 0. If we plug in 0, the top is going to be 0, the bottom is going to be 0, and you're going to get 0 over 0, which is the indeterminate form. If you have the indeterminate form, typically you will factor, cancel, and then plug in. And indeed, that is what we're going to be doing. So when we factor, I'm going to be factoring out an x squared. When we factor out an x squared, I'm left with a 5x squared plus 8. In the denominator, I'm going to factor out x squared yet again. And when I factor out x squared, I'm left with a 3x squared minus a 16. So I factored. Now I will cancel. And after I cancel, I will plug back in, meaning this 0 is being plugged in for this x, and that 0 is being plugged in for this x. If I have 0 squared times 5, this entire term is 0, this entire term is 0, meaning they're gone, and I'm left with 8 over negative 16. I'll write that down. This is 8 over a negative 16, which reduces to a negative 1/2. Again, a review question, but nonetheless, the answer is A. In number 15, I'm asked to find the slope of the line tangent. I'm not asked to find the equation of the line tangent. A lot of people think it's the equation. It's just the slope. I just need to take the derivative. I just need to find y prime. Because we are just trying to find y prime, I'm going to take the derivative. And I'm noticing it's giving us a 0.32, which means I have an x value and I have a y value that I can immediately plug in after taking the derivative. So let's take the derivative. Again, I see a powerhouse. That 2 is going to come down in front. This is going to be 3 times 2, which is 6. Y, I descend a power from 2 down into 1, so I'm not going to write that 1. And then I have to remember to take the derivative of the inner. The inner here is just a y prime. Minus. All right, the derivative of 2x squared is pretty straightforward. It's 4x. And then I'm going to write my equal to sign. And now I'm looking at that 6. The derivative of a constant is always 0, so I'm not going to write that down. And then I have this difficult problem of a minus 2xy. So this is always going to invoke product rule. Product rule is 1d2 plus 2d1. I am going to choose to make 1, the first function, negative 2x. That's my first function. My second function is going to be just my y. So when I say 1, it's really saying negative 2x, negative 2x. 1d2, the derivative of 2 is y prime plus 2d1. So 2 is y, and d1, the derivative of negative 2x, is a negative 2. I have taken the derivative correctly, and as I said before, I want to plug in my x and y coordinate as fast as I can. 3 and 2 are immediately going to get plugged in. Let's see what we have. We have a 6 times a 2. Y prime minus 4 times, the x coordinate is 3. That's going to be equal to a negative 2 times, x is still 3. Y prime plus, our y coordinate here is 2 times a negative 2. All right, so now I just simplify it a little bit more. I get 12 y prime is subtracting 12 equal to negative 6 y prime minus 4. All right, get all the y primes on the same side. Let's go ahead and move the negative 6y to the left-hand side by adding 6y to both sides. That's going to give us a positive 18 y prime on the left-hand side. Everything that's not a y prime, namely that negative 12, needs to be moved to the right-hand side. I'm adding 12 to both sides. 12 plus negative 4 is just an 8. And finally, I will divide both sides by 18. Therefore, y prime is equal to 8 divided by that 18. That is not reduced. I'm going to divide the numerator and denominator by 2, which is 4 over 9. A positive 4 over 9 is option B. Number 15 is B. All right, moving on to number 16. In number 16, again, I've seen this question before on a previous pretest. I need to take the derivative. Luckily, the derivative, at least for the outer of e house, is just e house. It's e to the 1 over x. Easy peasy. But don't forget, you need to multiply by the derivative of the inner. Dinner. The derivative of the inner is a little bit hard because the inner I'll write this up here. The inner, before we take the derivative, is just 1 over x. I don't like taking the derivative of fractions because that invokes the quotient rule. I'm going to rewrite this without a fraction. I'm going to say this is really x to the -1. And now I'm going to take the derivative, and I'm going to write that down here. The derivative of x to the -1, again, this is powerhouse. The negative comes down in front. I'm going to say negative x to the power of, I go down a power. If I am already at -1 and I go down a power, that's -2. And now I have my answer. I just need to find the right form. I'm noticing that all of these answers have an x kind of in the bottom except for b. So that means I'm using that negative power and I'm bringing this x down to the denominator. That means e to the power of 1 over x is still in the numerator, and this x to the power of 2 now, not -2, is in the denominator. Don't forget that negative still needs to be in there somewhere. It doesn't really matter where you put it. And I'm noticing some people put the negative out front, and it is just going to be a negative out front. You can either put the negative on the top, on the bottom, or out front, but not both. I guess you could do all three technically. That's just weird though. All right, so, and that is exactly option A. Number 16 is A. Moving on to number 17, this is our last page for our pretest. Number 17, we're given a graph of f of x, meaning it's just like y. And then I'm given multiple choices that are f prime. So I'm trying to identify f prime candidates on both of these. I think usually the way that I solve these is I start with the right-hand behavior, which is a little bit of a shortcut. The right-hand behavior, if you look at the right side of the graph, is it going up or is it going down? The right-hand behavior in my original graph is going up, which means when I take the derivative, or if I take the antiderivative too, it will always be going up as well. Notice that on option A, it's going down, which means A is eliminated. B is also going down. B is eliminated. C is going up, so it's still in the running. D is going up, it's still in the running. And E is also going up, it's still also in the running. But I've eliminated two choices, just knowing that right-hand behavior never changes when I take the derivative. From here, I'm going to identify points of interest, namely f prime. So on a graph of f prime is slope. Slope equal to 0 is a great candidate for finding interesting correlations between the two graphs. F prime is equal to 0, f prime is equal to 0, and f prime is equal to 0. That's where our slope was equal to 0, where we have those horizontal tangents. So when I switch to a graph of f prime, those should be heights instead of slopes, because on a graph of f prime is height. I should be seeing a height of 0 there, there, and there, here, here, and here. I should have x-intercepts here, here, and here. Let's go and see where those x-intercepts are. I should be looking here, here, and here. None of those were options, therefore C is out of the running. I'm looking at option D. I should be looking at those x-intercepts. Again, roughly, they should be happening here, here, and here. None of those are quite right. D is out of the running. And I should be looking for options there, there, and there. Oh, look at that. That's perfect. That is exactly where they are. So option E is the correct answer. And yet another tool that you could have used is every time that you take the derivative, again, this was f and these were all f prime, I'm taking the derivative. Every time that you take a derivative of a graph, you get one less turnaround spot. So notice I had 1, 2, 3 turnaround spots, and I'm using that term loosely. And when you take the derivative, you should have 2 turnaround spots, which kind of leaves you between option A and E. And using the right-hand behavior, you could just eliminate option A and really get E much faster way. But I like doing my way better. All right. Number 18 is rough. It's hard because you're looking for the second derivative. This one is asking for y double prime. Luckily, it gives us a point to immediately plug in, but it's still tricky. So let's go ahead and go nice and slow, make sure we have this down. And I'm noticing it already has y prime. I'm going to swap this dy dx out for a y prime. All right, so in order to have a y double prime, I need to take the derivative of that y prime term, and that will turn into a y double prime. I'm just nervous because this is going to be product rule in some way, shape, or form. I'm just going to go ahead and brute force this and not do too much thinking. I think that's probably the fastest way to do it. I was thinking, oh, maybe we can distribute the y prime first and then take the derivative, but then you're doing 2 different product rules. I don't think I really want to do anything. I just want to do that one product rule. So how do I know it's product rule? Well, I have multiplication with variables happening. So I'm going to say this entire thing right here is product rule, 1d2 plus 2d1. And I'm going to call this function my 1 and this y prime function my 2. All right, so when I say 1, I'm saying x plus 2y. 1, d2. d2 is the derivative of y prime, which turns into y double prime, plus 2, which is y prime, times d1, so times the derivative of everything in here. The derivative of x is 1, the derivative of 2y is 2y prime. All right, product rule is done. I can say equal to, I'm going to take the derivative of the right-hand side. The derivative of 2x is a 2. The derivative of negative y is a negative y prime. All right, I said it before and I'll say it again. As soon as you can, you want to plug in your X and Y coordinates for these types of problems to make your life as easy as possible. So when I start plugging in my X and Y's, let's see what happens. When I plug in my X and my Y's, I get my, my 3 here. This is a 3 plus 2. Okay, my Y coordinate is 0. Y double prime, the thing I'm trying to solve for, plus, this is going to be a problem. I'm going to leave you as an empty slot for now, but I'll leave a note that that's my Y prime here. That's going to be times 1 plus 2, another empty slot, that's supposed to be my Y prime there, is equal to 2 minus yet another empty slot that needs to be filled with my Y prime. You'll notice that the only thing I really need to do is solve for my Y prime. How would I do that? Well, the answer is we have an equation with Y prime in it. We could have plugged in right from the get-go. Watch what happens when we do that. I'm going to rewrite this entire equation to solve for my Y prime, where all these X's and Y's get swapped out for my 3's and my 0's. So I'm going to write that over here on the right-hand side. So I'm going to say X is now 3 plus 2Y plus 2. Okay, my Y coordinate is 0. And that is all being multiplied by my Y prime. Again, I'm just rewriting this formula. I'm now rewriting that equal to sign, and I'm going to say this is equal to 2x. So 2, my x is 3, so I'll write a 3 here. And then minus y, minus my 0, minus 0. All right, and notice that in this equation now, I have only one variable to solve for, my Y prime. Let's go ahead and simplify as much as possible. This is going to be 2 times 0 is 0, and 3 plus 0 is 3, so this is going to be 3 Y prime on the left, and this is going to be equal to 6. Hey, divide both sides by 3, and Y prime is equal to 2. What an easy value to plug in. All right, so remember all those empty slots that I had a Y prime earlier? Those 3 slots are now a 2. So let's go ahead and say that's a 2, that's a 2, that's a 2. All right, I am running out of room. All right, you guys are going to have to move. You guys can move up there. All right, so now I'm going to come over here, and I'm going to simplify. So yet again, 2 times 0 is 0. 3 plus that 0 is 3. So I really have a 3y double prime right here. 3y double prime. And I'm going to copy down the plus sign, And now I have, let's simplify it. 2 times 2 is 4, plus the 1 is 5. So this whole thing is 5 times 2, which is 10. All right, so that's going to be plus 10 is equal to, on the right-hand side, I have 2 minus 2, which is 0. All right, this is much, much easier now. Let's go ahead and subtract 10 on both sides. So I have 3y double prime is equal to a negative 10. Divide both sides by 3, and y double prime is equal to a negative 10 thirds. Please be an answer. Oh, I see there was a positive 10 thirds and a negative 10 thirds. We want the negative one. The correct answer for number 18 is A. Whew, a lot of math. 2 more problems left. We're almost there, guys. All right, number 19. I'm seeing f double prime, and we're looking for inflection points. Again, the definition of an inflection point is whenever you have f double prime having a sign change. And this one is really fantastic. Look, we're looking for f double prime. It gave us f double prime. You are so nice, Mr. Sindel, or whoever made this test. F double prime is done. We just need to look for a sign change. A sign change can only happen when we have factored forms. It already gave us the factored form, and we are looking for odd powers. This is a power of 1, and a power of 2. This is an even power. This will not change signs. That will not be an inflection point. These two will be sign changers. When I set them equal to 0, this one, here I'll even write in pen, this one will give us 0, and this one up here will give us x is equal to a negative 1. So those are the only two values that will change signs because their factors have odd powers. All right, so 0 and negative 1 is option C. The correct answer for number 19 is C. You have to do very little writing, very little thinking. It's kind of fantastic. Last problem on the pretest. Here we go. Oh boy, natural log, and it's asking us to find y prime. Again, whenever you see dy dx, it's asking for y prime. All right, so take the derivative of the left. The derivative of log house is 1 over whatever the inside is. So it's going to be 1 over the inside stuff, which is 2x plus y. This is going to be equal to the derivative of the right-hand side. The derivative of x is 1. The derivative of 1 is 0, so I'm not going to write the plus 0. All right, that's incorrect. And I'm realizing I did doubter and I forgot to multiply by the dinner. How dare you, Mr. Sindel? Let's move you over and multiply by the dinner. So there's my slot for my dinner. The derivative of the inside, the derivative of 2x is 2. The derivative of y is y prime. So I'm going to say plus y prime. And now I have the correct way to do this. Now I can just simplify. So I'm going to do this simplification in a few steps. Let's move you up. The first thing that I'm going to see is that this is really all over 1. And whenever you multiply fractions, you multiply numerators, multiply denominators. Let's see what we really have. We have 2 plus y prime all over 2x plus y is equal to 1. All right, and technically it's 1 over 1, but I'm going to, some people call this the butterfly method, but I'm really just going to move this 2x plus y over the right-hand side by multiplying both sides by 2x plus y. When I do that, I get a new equation that says 2 plus y prime on the left-hand side is equal to 2x plus y on the right-hand side. And then from there, I just need to get rid of my 2, and I will isolate my y prime. So to get rid of the 2, you subtract 2. Y prime, therefore, is equal to 2x plus y minus the 2. 2x plus y minus the 2. Oh, in the exact order and everything is option B. All right, that does conclude the entire pretest. Let's go through each of these pages so you can see them all in one glance. There's page 6, page 5, page 4, page 3, page 2, and our original page 1. Go ahead and give yourself a score if you have not done so already. Convert it into an AP score, and thanks for watching.